All right, and so the volume is the integral minus 6 to 6, 144 minus 4x squared dx. So I know you, I don't want to say this. You know how to do this on your calculator, your TI 83, 84?
Um, do I know how to put in an integral on the calculator?
Yeah, because it will do this by hand perfectly,
How
and it
do
might be worth learning how to do that.
okay. I don't know how to do that. Do you?
Well, do you have an 83 or an 84?
An 84.
Okay, so yours is you're going to go to math 9,
Okay, math.
and it should put up an integral symbol.
Okay, yeah, FNLNT. Yeah, okay.
Okay, and so you should be able to put all of this into the calculator and get a
Oh,
result.
okay. See. I didn't even know you could see that. Okay. I got 1,152.
Should be a fraction, maybe. Or it's exact.
Let me see. Maybe I put it in. That's what my calculator's giving me.
Okay, let me double check here.
Okay.
Um, so um, like there's a ton of these available on the internet, so you just pick one that you like. There's not like a right or a wrong, especially if you're doing these by hand. Um,
Mm-hmm.
sorry, just for the delay, it just wasn't set up. 144 minus 4x squared from minus 6. Sorry, you're correct. I don't know why I expected to see a fraction, but that is the answer.
Okay. That's okay.
And the answer doesn't really mean anything. So like when you get a number, I don't try not to like wonder if it's correct. You should just check that, maybe do the calculation twice or do it like, do it and then wait and do it again or redo the problem because the answers don't mean anything. Like
Okay.
there's no like, oh yeah, that makes sense, I mean,
Okay.
uh, it's not like a pint or I don't know what you're having out there, but it's
Yeah.
it's it's like, oh, it's a pint or that's 2 pints or whatever. We don't necessarily always have a meaning. So this is uh this is a different problem than the first one. It says find the volume of the solid by revolving the shaded region about the x-axis. So there's two types of revolving problems. The first is the disk method, and the second is the washer method. Do you own any discs, CDs, DVDs,
I
Blu-rays?
yeah.
Okay, so you know what I'm talking about. Some people are like, I don't know what a disc is. Like, all right, well,
Yeah.
it's the cassette method. No. Um, the the thing here is that it's the formula is the integral, and again, it's from A to B. This is the volume, and it's the disk method. There's a radius function of x. You're like, what is this R of x? R of x is this is R of x here, and this is R of x here. So it's the height, and basically you're going to solve for y. You can solve this for y. That's your R of x. And the radius changes. Like it's smaller down here, it's bigger down here. Because what's happening is you're creating these disks, which it's hard to draw here, but you can imagine these disks like that.
Okay.
That's kind of what is happening here. Books do a little better job of that. Dx. So there's a dx here. So your dx is always there. So in this case, it's from 0 to 1, 2, 3, 4, 5, 6. And then your radius function, you go solve this for y. So y equals 30 minus 5x divided by 3. So maybe go, sorry, there's a bit more here. Pi r squared. sorry, left all that out. The area of a circle, pi r squared. So it's pi, your radius function is 10 over 10 minus 5/3 x squared bx, like that. All right. And see, the nice thing about your calculator is you don't have to simplify this. Now, if you're doing it by hand, you do. Okay. Now, here's the thing with your calculator. You cannot do not put a pi in your calculator ever. Your
Okay.
pi is just part of the answer. So it's like, do everything but the pi in the calculator. And why don't you try that again and see what you come up with for this, if you don't mind.
Yeah, of course. I got 200. 200 pi? Is that what it would be? I don't think I can hear you if you're talking. I don't know if you're
I
talking.
apologize. I don't know why I muted myself. That's really
No, it's
silly.
okay.
Um, yeah. Well, it's kind of like when you're out and you start saying things, you don't know if anybody's hearing you, and or um, I don't know. Okay. So this problem here, there's no graph. And you could graph this. And
Mhm.
and I mean it is a good exercise to do. Like what does the graph look like? Well, it's this, and there's 2, x equals 2, again, not to scale. There's y equals 0. So it's this region right here. Okay, it's this right here. Now, the y is almost always your r of x. Like you don't have to overthink that. This is going to be one of your bounds, uh, whether it's that. So in your problem here, it's the integral from 0 to 2. 2x squared squared makes you square that whole thing, and then a pi again.
Okay. So am I putting this in the calculator?
Yes, yes.
Okay. I got 25.6.
Like repeating or
It's just 25.6, like no
okay. Yeah, so if you ever if you ever being that can do the math, enter, and that will convert it to a fraction because you
128 over 5.
yes. So that's what you want here. And again, like what is that? I have no idea. Like that doesn't mean anything.
But plus pi, right?
Yes,
Like,
there's a well, not plus pi, times pi.
yeah, times pi.
Times pi.
Yeah, that's what
Okay.
I mean, like
Yes.
out of pi.
Yeah. And And okay, there you have it. And you can kind of see the pattern here. So let's see what the next one is. Number 4. Um, I'm gonna I'm gonna quickly graph this one because there's another little thing you can do to make these sort of like where you never get them wrong. But I wanna 0 pi over 3 3 pi. Okay, yeah. So again, this is number 4, and again, you just do the math. You like, all right, volume is integral pi. Um, x1 is your A, x2 is your B, pi over 3 to 3 pi over 4. Okay, 3 square root sine like that squared. Yeah. So this one's not going to work out as nicely. Um,
Can I
what
still
do I?
put it in the calculator or no?
Why don't? Oh, so good news. Um, this is why you got to look at the Pearson. This is even better. This is the best case scenario. It says round to the nearest hundredth. So you put the whole thing in your calculator with the
Okay,
pi. When you're rounding, just write in the calculator, boom, go, and let it do the work
so
for
I
you.
add the pi in this one.
Yes.
Okay. Oh,
Oh, make sure your mode is in radians. That's
okay.
also a really important thing. Uh, make a note here. That could get messy if it's in degrees. Because again, the answers don't mean anything. You're just like, oh yeah, there you go.
Yeah, I got round to the nearest hundred, so um 34.13.
Got the same.
Okay.
Very good. So in some ways, these are easier than earlier problem sets, because you just go
Yeah.
right to the calculator. But there's potentially some exceptions here. Let's see if any of these so far have them. All right. Okay, so here is number 5. I'm going to quickly graph this just to give you a little bit of background on what is actually happening here. And then
Okay.
we'll talk about how to do it, which is less complicated than may appear. All right. So if you notice, this problem says to revolve it around the y-axis, and all the previous problems have said to revolve it around the x-axis.
Okay.
Okay. And I've graphed it here. So it's this region, but you're going, and they sometimes show it like a little wheel here, a little rotating thing, wheel of
Hmm.
death on your computer. Thank goodness our phones don't get that very often, at least. Um, but this is going around the other direction. You're like, oh my God, what do I do different here? Well, for these kind of initial problems, you don't do anything different. You do them the same way. You just treat this as A, this is B, and this is your radius function. Now I know it's y instead of x, so you change it to x. So this is from 0 to 5, 2 over the square root y plus 1 squared dy. Now in your calculator, so your calculator doesn't care whether it's x or y, so you just make it an x and an x.
Okay.
And all the other problems we can go in the other direction, but here we're going around y. It's the same problem. We'll figure out. We'll get to some exceptions, and we'll.
I'll just put that in the calculator again.
Yep. Go ahead and just try that. Let me look and see if it says exact, rounded. It does say exact, so no pi,
Okay.
no pi in your calculation. Um,
I got some huge number over some huge number.
Yeah, so oh boy, unfortunately, this one doesn't work out on the calculator. So we do
Okay.
have to do this one by hand. Let
Okay.
me go ahead and grab it here. Yeah, I mean, so your first is to go to the calculator. Now, keep in mind when you have multiple choice answers, right?
Yes.
So you go to your calculator and maybe you got a number. If you put the pi in, so sorry, let me back up. If you're doing this on the exam, you go right to the calculator, okay?
Okay.
And then you compare your answers to the multiple choice.
Mm-hmm.
So like your answer with the pi is going to be around, I'll just say 22. And you just calculate the ones, and one that's 22 is is your answer. But
Yeah.
unfortunately, to this one we have to do by hand. It's 4 over y plus 1, integral from 0 to 5 with pi by. So this is and I'll do it for here. It's the natural log absolute value of y plus 1, and you're evaluating from 0 to 5, the pi there. So it's 4 pi natural log of 6 minus 4 pi natural log of 1. So you're putting that, remember we put that top bound in, and we put that other bound in. It's top minus bottom, like that. Does this all look familiar to you or totally foreign?
It looks familiar, yeah.
Okay, like the integral part, maybe you don't remember, but hopefully the top minus bottom is natural log of 1 is 0. So this part is 0. So you end up just getting 4 pi natural log of 6. Like that's your answer. Which again, like what does that mean? Like I don't know. I really haven't, these don't mean much. I actually got on Twitter arguing with a guy about like in calculus 2 especially, you do a lot of problems like this and there's no physical meaning to these things. And I'm like, why are we having students do this?
Yeah. Understandable. Yeah.
Uh, you know, didn't get a great reaction. So all right, so here is one. This is a problem that requires a little more effort
Okay.
um, to do. So, if you didn't know any better, you'd probably be able to get this far. Pi integral 0, 3x squared dx. And you might actually put 6 up here. Okay. This would be wrong. So the only thing we don't have is this upper bound. So
Okay.
that's where you need to like, and this is where a lot of students struggle. You need to be able to graph these things. So this is y equals 3x. This is x equals 6. And we need to figure out this intersection point.
Okay.
So to do that, I mean, you just literally, I'm sorry. No, that's not right. Uh, sorry, I messed this up really bad. Let me back up.
Hmm.
Um, that is not right. Y equals 6 is up here. Y equals 6 is up here. So, and this is so this is, and again, that's what you might do, but this is actually wrong. So, um, hang on, what gets wrong? So you have to first set these equal. Okay, so 6 equals 3x, x equals 2. That's the upper bound. But the thing is that it's this piece is what you're revolving this time.
Okay.
So this one's different. So see how there's okay, and this is where I wish we were in a classroom because I could like see how there's a void here. There's a space. Like
Yes.
all the other problems, it was like it butted up right up against the one that you're revolving around. So
Hmm.
this one's a little bit. This is called the washer method. Put that here. And if you're not like in the hardware world, I think a donut method would be better. I think everyone knows what a donut is. Donuts have holes in the middle.
Yeah.
So I was working in California, out of college, and it's this man that I worked with, really a brilliant guy. His name is Yuri Vilms. He's since passed away. Brilliant guy, and he had the worst jokes though. He would come up to me and he'd say, Matthew, did you see that they have donuts in the break room? And I'd say, yeah, I saw that. He's like, did you know that the healthiest part is the middle, referring to the hole there.
Yeah.
And, yes, Yuri, that's hilarious. You know,
Yeah.
uh, okay, let's get back to work. Uh, this one has a void though. So the radius up here, and it's a little bit complicated. It's got a top part. It's got like a what's called a big R and then a little r down here. So it's different than for this. So this is actually wrong. It ends up being, and I write it this way: big R of x squared minus little r of x squared dx. Okay. And it's again the top minus bottom. So the big radius is the 6. And the little one is this 3x squared like that. Okay, so like it takes a little bit to get the setup, but you go right back to your calculator. 6 squared minus 3x squared dx. So
Okay.
go ahead and give that a try, I guess. No pi when you're doing your calculator thing.
I got 48, so it'd be 48 pi.
It sounds good to me. All right, so 7 here. Let me just look ahead here and see if we can get, if there's any, oh boy, they just keep going and going. All right. Um, ugh, can't believe you get 25 problems of these.
I know.
Was it 6 we just did?
We just did 6, yeah.
All right, so I'll go to 7. All right. This one's actually not bad. They give you all the information. So it says the region in the first quadrant bounded above by the curve y equals x squared. So first quadrant is over here on the right, and below by the x-axis on the right by x equals 1. So not to scale, and then your and then -3. So it's all of this region. So this one's not, this one's a disk because it butts up right up against uh so it's from -3 to 1 pi, and then it's x squared dx.
And I put that into the calculator.
Yes, sorry, yeah, long silence, yes.
— 244 over 5 pi.
Okay, very good. All right, number 8. Right. So this one is again that kind of like it's in terms of it's in terms of y. Let me get it on here on the screen, but you just treat it like x. So it's integral 0 to square root of 5 because it butts up to the axis here. Wait, oh, this is the shell method. Never mind. Um, let's get back to that. So I don't know if we want to do shell method. Oh, just looking ahead here, trying to see. Can we just switch to some arc length ones, or do we want to go full on?
Whatever you think is better.
They're all the they do, this like for me, this is the same as solving, like a system equation. So it's up, I guess it would help here. There's there's when you do the shell method, and so you don't have to do the shell method. Um, let me just see here. Um, Sorry, I'm just trying to like this. Like it's really complicated to explain the shell method. We need a little build up to it. So let's do arc length. How many arc lengths do you have? You have two. Okay, let's do arc length. Hey, can you come back to this one? Let's go to 11 if that's okay.
Okay.
Oh, this is an exact answer. Oh my gosh. Okay. Sorry, this is just I can't even believe you're doing this in the course.
Oh no.
Calculus 2. All right. So arc length. Let me pull up a reference so that you can see how to do these. And one of the hardest things in the calculus 2 is all the formulas, all the things that you need to know. And for arc length, it's a pretty basic formula, but because it's for both x and y, it looks really complicated. But the arc length is just the integral of what's called ds. And what is ds? Well, it's the square root of 1 plus dy dx squared. So what you need is a function like this, and then you have to be able to take its derivative.
Okay.
So this is where it's like, oh, derivative, how do we do that? You got to remember, okay, it's power rules. So you bring that down. So it's 3/2 times 2/3 x squared plus 1 to the 1/2 power, and then times 2x like that. And so these cancel out in front, and then you have to square your derivatives, but we'll do that in a moment. So it's ends up being 2x square root x squared plus 1, and you have to square it. So it's 4x squared times x squared plus 1, which ends up being 4x to the 4th plus 4x squared. And that's this part in here. So this becomes the integral from 3 to 6 square root 1 plus 4x to the 4th plus 4x squared dx. Why don't you try this in your calculator? I
Okay.
don't know if it's going to give you the right thing. There's one more step here that will, and that's what I'm trying to avoid because it's complicated.
I got 129.
Exactly, or
Yeah.
okay, good, 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 good. So that is the answer. Um, Now, what I was going to show you is that this actually factors into 2x squared plus 1 squared, square rooted,
Mm-hmm.
and then the square root cancels the square. And then it works out nice. It ended up being 3 to 6, 2x squared plus 1 dx. So why don't you try this one? You should get the same result, but why don't you
Okay.
try that just to make sure? Um,
Yeah, I got 129.
okay. All right. That's good.
Mm-hmm.
That's good there. The next problem here, 12, is another arc length problem. If I can find it. Let's see. Just a second. Now, oh, this is okay. This is okay. fractional round to the nearest tenth. Yeah, yeah. So this is good because it says to round to the nearest tenth. That's always a good sign. That means you go right to your calculator. Okay, but it's the same formula as before, but this time it's in terms of y. And see how this is x equals a function of y instead of the previous problem was y as a function of x. Like it's a little difference. If you're doing it by hand, it's maybe important, but um, it's the same setup here. You have to take the derivative of this thing. Okay. And that's maybe the hardest part here. It's like, what is the derivative? Well, uh, let me grab it and we'll rewrite it. So x prime is actually, let me rewrite this slightly because I think this would help. X is really 1 over 18 y cubed plus 3 over 2 times 1 over y. All right. And then it's power rule for the first one. So it's 1/6 y squared plus 3 over 2 minus 1 over y squared. Okay. So just a little cleanup here. 1/6 or maybe just y squared over 6 plus, or maybe minus, maybe do it that way, minus 3 over 2 y squared like that. That's the derivative. And then you want to square it. Now, the thing is, you don't have to actually square it. You can just show it's squared, especially since you're going right to the calculator. All right, so the formula here is the arc length is the integral from 3 to 5. Where do the 3 and the 5 come from? Back in the problem here, it says from 3 to 5. The square root now, the square root of 1 plus, this mess over here on the right, y squared minus y squared over 6 minus 3 over 2 y squared squared dy. Now your calculator, you're gonna have to use x instead of y, but because you're rounding to the nearest tenth, this should do it for you.
Calculator.
Yes, right to the calculator.
Just want to make sure.
Be careful here. You're gonna need parentheses around this on the bottom in your calculator. And
Okay.
I'll also do the calculation because I'm sure I know you're getting this as a grade, so I don't want to make any sudden problems here. X squared over 6 minus 3 over close, close, close. So mine actually worked out. Well, I'm
Yeah,
using
that's
it
what I
ends up being
thought.
5.6444. I don't know if yours worked out nicely.
Yeah. 20,
Okay.
254 over 45 when I did the
Right.
calculation.
So when there's a choice, you want to use the fraction. Like, so I'm glad that worked out there for you. Um, we did 8. No, we did not do 8. 9 was a better one to do, I think. Yes, 9 was better. Okay. 2 pi. All right, let me little background on this. shell method. Oh, sorry. So the donut method, I apologize because I don't follow them. Sorry. Washer. They call it the ring method. I guess that's a better a better example. Um, sorry, side point on that. Oh, 2 pi radius times that. They don't give you. Just looking to see if they give you a better thing here. Okay, let's see here. Let's grab your problem here. Number 9. Nah, that's why they did 8 first. Okay, I guess we will do 8 first. Just to keep it really simple, the shell method, this is really gonna be really confusing because we don't have any, you're not getting a lecture on this, but it's the integral from 0 to square root of 5, which is the the y bounds here.
Mm-hmm.
And then it's the formula is it's 2 pi y, which isn't really y, it's really y as a function of x times um times the height. So they call it, how do we do this? How do I so let me just put it here. Y times 2y squared dy. I don't like that, but this is the base and this is the height. And it doesn't make any sense. Really need a formal explanation, which would take a full hour. So
That's
you
okay.
can, yeah, I know it's not what you're looking for. Make sure you pull this pi out.
So,
You,
okay.
but you can do this in the calculator as well.
Okay, so I would do,
It ends up being 2 times y times 2y squared.
okay. 0 square root of 5. And then it'd be 2 times y times 2 squared. Or is that squared or should this, that's squared? I was gonna say
Yeah,
not
sorry, squared.
7.
Yes, yes.
Okay. I got 25.
Okay, and then you're gonna throw in that pi with it.
Yeah,
Yeah, there you go.
25 pi.
Okay, we do have to stop there.
Okay.
Thank you for scheduling